All right, so today is March 13th, and we are working on 9.3, Technology Corner on page 569 with we are talking about a test statistic for mu, for the sample mean, t-distribution, and we are talking about being able to plug it in our calculator. So this is a real quick business. You can use the t-CDF, so that's for the t-distribution, and we're talking about an area under a curve. That's why it's CDF and not PDF, and on either one of these, and this is the gameplay, how to do it. Okay, so if you're using the black calculators, the solid black calculators, which I think is just the TI-84. I don't know if it has, I don't think it has a plus on it. I can't remember. Lower bound, upper bound, and then degree of freedom. Now, if you have one, a TI-83 or 4 plus CE, any of these, it's going to ask you for those specifically. So, now, we did not, okay, yeah, we can put it in ourselves. Okay, so we're going to use this information from the batteries, and so hit second on your calculator, and the VARs button, so here I'm going to do it here. I've already hit second, VARs, and then you're going to go to number 6, TCDF. Now, the lower bound, this is really lower. Mine in college, my guy used to say hit negative 400, just something very low. It's the T-score. It's going to be so far out. We're getting, all of the area that would be just measurable. So something very negative, that's usually what the calculator gives you. And then the upper bound is this. I probably already did it on here. No, I didn't. This is a different one I did on here. Okay. So we want it greater than, this is totally, I did a different one on here, sorry. We want it greater than 1.54. So that means our lower bound is going to be 1.54, and our upper bound is going to be something very large. You can use 100, 400. That's just what my teacher told me to do in college. And then 14, because our degree of freedom is 14, since our what was 15? Our sample size, that's right. So there you go. And this is the area to the what? Right or left? To the right. This is a t-distribution, right? And because we told it the lower bound at 1.54 and the upper bound 400, then it's giving us everything to the right. Okay? That's what's nice about using it on your calculator. Now, so that's how to find the area really quickly. Now, if we do the two-sided test to find the p-value for the two-sided test with degree of freedom, so this is just some information, it's fine, just put it in. Degree of freedom 36, and this was, I can't remember what scenario this was. This was the, I don't know what those are, I can't remember. It's just a scenario, it's not, I don't think it had a story problem with it. Okay. So degree of freedom of 36 and t equals negative 3.17. Now, this time, you can do 2 times the tail. However, let me see here on this one. This is a TI-84 plus CE. So if we go second VARs, 6. Okay, so we are going to need to do that. So let's go back out. I'm going to hit second mode to quit and do 2 times second VARs, 6, and we can do the negative 3.17. It's totally fine. So we're just going to multiply the area times 2. That's what we did the 2 times because we want both ends. So the lower negative 1, that's really, really low in the t-score. And then negative 3. What did it say? 17. Okay, and degree of freedom of 36. And notice when we did it in the book, we had to use a degree of freedom of 30 because it didn't have 36, right? And so we multiplied that times 2 because we not only want the lower end, but the upper end. And they're identical, so you can just multiply times 2. Everybody good? Okay. And so there would be the area under both ends. Okay, Elise, you look like you have a question on your face.
No.
You're good? Okay, good. Okay, so there we go. That one's that one. So let's jump over and look at page 573. Thank you. Okay, now, this is one sample t-test on your calculator. So you can perform a one sample t-test using either raw data, so you would put that in your list 1, right? Or summary statistics on the TI 8384. Let's use the calculator to carry out the test of the null equaling the mu is 5 versus the alternative where the mu is less than 5 from the dissolved oxygen sample, the one we were just talking about with the fish. Start by entering the sample data in list 1, then do the test. Okay, so we need to jump over to that example, and that is on page 571. It's right here. So we're going to first hit second plus sign. That's going to hit number 4 for clear all lists, and then put these numbers in, and we will do that really quickly. So stat 1 for your to get to list 1, and then we'll start entering those in. I need some elevator music to pass the time. Oops. No, that's right. Okay, so when you do that, don't forget you should be on list, your blank should be on 16 because you had 15 entries. Is everybody there? Okay, so then, like you guys said before, where am I going to go? Uh-huh.
Test.
Well, first we're going to go to calc. Oh, well, hold on. No, we don't have to do all that. It's doing it for us. Never mind. Test, you're right. Okay, so we're hitting stat and then choosing test, and we want number 2 for the t-test. Okay, so go over, that's right, Elise, go over to test. We want the t-test, not the z-test. Number 2, and we have to put in some information now. Okay, so we're going to do data. So arrow over, make sure your data is highlighted. And then the mu is 5, remember, because that's what, I don't know, whatever people that are measuring this or claiming or hoping that it's at least 5 for the fish to be alive. Now we're getting our data from list 1, so that's good. Frequency can be 1. But our concern is what? Is it just that it's not 5, it's less than 5, or it's greater than 5? Less than 5. We don't really care if it's greater than 5 because that would be still good. We care if it's less than 5. We're concerned. So we're going to leave that. And then, now, if we hit calculate, it's going to give us information. If we hit draw, it's going to give us the curve with the area of a concern. Okay. So let's hit calculate and see what we get. Okay. Whoops, I need to scroll that down. This is the one I want you to be looking at right here. Bring it up a little. Okay, so the alternative is the mu is less than 5. That's what we got right here. The t is not the same. What did I do wrong? Well, that is horrible.
You must have entered something.
Maybe I did. Okay. Did you guys get the right numbers here?
Yeah.
Ah, I'm really sorry. I'm sorry this is going on the internet. Okay.
Cut it out.
Do what?
You could cut it out.
Cut what out?
This part of the video out.
Oh, okay. I may have just put something in accidentally. I don't know. I don't know. Okay, well, they all got it right, so let's go with that. I'll have to figure out what I did wrong, not take up your time. So here is the t-value, the p-value, the x bar, and the s sub x. So your sample standard deviation, your n. Now, if you go back and do that, go to the test and hit draw instead of calculate, it's going to draw this area to the left. So that is our area of concern, right? So they're saying, what is the likelihood of getting the sample size that we did if the mu is actually 5, or the mu is actually 5, which is their claim. So what's the likelihood? Well, that is this area here. So that's where we can get it. And now we're going to go on and do some sample problems. What was the number that you wanted to do on the homework? 63. Okay. It's okay, that's fine. All right, so let's look at this. Okay, I'm going to go run and get the book so we can go pretty quickly and we can get more than one in. So go ahead, Ronnie, can you read that for us loudly so that people can hear it?
The Survey of Study Habits and Attitudes, the SSHA, is a psychological test that measures students' attitudes towards school and study habits. Scores range from 0 to 200. The mean score for U.S. college students is about 115. A teacher suspects that older students have better attitudes towards school. She gives the SSHA to a simple random sample of 45 of the over 1,000 students at her college who are at least 30 years of age. Check the conditions for carrying out a significance test of the teacher's suspicion.
Okay, so I'm going to do it on some paper so I can, instead of the board, so I can put it on here. So now, well, always, as I say you're taking this a test, and it's not like in the mean section, so you have to say to yourself, is this proportion or mean, right? So the mean score, well, there's a big hint right there, right? The mean score of U.S. college students is about 115. Okay, a teacher suspects that the older students have better attitudes towards school. She gives their high school to a simple random sample of 45 of the over 1,000 students in her college, not high school, this test, sorry, who are at least 30 years of age, so older students in the college. Okay, check the conditions for carrying out a significance test of the teacher's suspicions. Now, so what are the first things we need?
Do we, when it says check the conditions, is that like random, normal, and independent?
Yeah, they're only, actually this is all this is asking us to do, is or check the conditions. So we don't even have to, I thought we were going to do a big thing on it. So what do you think? What are the conditions? What are the 3 conditions that need to be met? Random, normal, and independent. Okay. So can I say that this is random? And if I can, how would I say it on the exam?
Yes, because the description of the experiment says that she took a simple random sample of 45 students.
Okay, good. Of her college. That's fine. Okay, normal. Is it normal? Elise, what do you think?
Yes, because the sample size is bigger than 30.
Yeah, so that's nice because we're already over at 30. We don't have to do any testing of it, right? Okay, good. And what about you, Hannah? What about independent?
That's the one with the 10%, right?
Right.
So you would just check if it's 10% of the population, less than 10% of the population?
10% or less, right.
And if it is, it's independent.
Okay, so, yeah. So you have to actually do that. So how would I actually do it?
45 times 10 is 450, so there's likely that there's more than 450.
Well, they've already said 1,000 students. So 450 would be, Right. 45 would be 10% of 1,000. I mean, 450. So it's definitely less than 10% of 1,000, right?
Mm.
So we're good. Okay. All right, perfect. Now, do I have another one to do? Okay, let's see. What about one that,
Like 83.
okay, let's do 83 in just a minute. I want to check 65 for just a second. It's not a super long one. Okay, so I'm not going to read all of this. They're telling you there's a story problem, and there's less than 30, and we did not tell you that the population was normally distributed, so you have to test, right? How do we test?
We put it in our calculator.
Okay, we put it in our calculator, and we test one of what? One of different things. What are some of the things that we can test?
Histogram, box and whisker plot, and a dot plot.
Histogram, box and whisker plot, dot plot, and a normal probability. If you put it into z-scores, right? Okay, now they tested a histogram. So look at this one. That you didn't have to do it. They gave it to you. So let's look at this on 65. Can we carry out this t-test with this one? Is it fairly normally distributed? That's the question. No. It's way skewed to the left, right? So I would say this is not going to be robust against this, right? It's not going to work because you have this crazy looking situation. All right? Okay, good. What's the next one you want to look at?
83.
83? I thought you said 73. Okay, 83. Let's jump up. Okay, 83 is right here. Let me get that a little clearer. Okay, fast connection. How long does it take for a chunk of information to travel from one server to another and back on the internet? According to the site .com, a typical response time is 200 milliseconds. That is not very long. About 1/5 of a second. Researchers collected data on a response times of a random sample of 14 servers in Europe. A graph of the data reveals no strong skewedness and outliers. So they're already saying they've checked the conditions. So they're moving on. They're getting ready to give you some data to look at. So they've already did in the graph, and there's no strong skewness or outliers, so the small sample size is okay. The figure below displays mini-tab output for a one sample t interval for the population mean. Is there convincing evidence at the 5% significance level that the site's claim is incorrect? Use the confidence interval to justify your answer. So they're going to give us a confidence interval also. So here's the mini-tab information. I'm going to zoom in a little bit because it's so not very readable. Okay. Okay, maybe you can see that pretty well. Okay, so we have, I have to look up there because it's so tiny on my paper. Variable n, there's our 14. This is response times. N is 14. The mean, they gave us 1.7393. A standard deviation of 27.21. The standard error of 7.27. And there's your 95% confidence interval. Okay, so what is this says, is there